When you're starting a new mapping project in your GIS software, one of the very first decisions you're going to have to make is about the coordinate system. You may choose a geographic coordinate system, and that's based on a three-dimensional version of the Earth. So that's treating the Earth as a sphere or a slightly flattened ellipsoid. But the idea is that the coordinate system that you're using is based on latitude and longitude for a three-dimensional spherical version of the Earth. The other choice you have here is a projected coordinate system, and that's based on using a flat two-dimensional version of the Earth. So you're taking the Earth, you're flattening it down onto a sheet of paper or onto a screen or however you want to think of it, and then the consequence of that is that there will be effects to that. It'll be squished, it'll be distorted in some way, and that will affect the way that your map looks and the way that people may interpret it. So from the very beginning, you have to make this choice. You have to decide, am I going to use a three-dimensional geographic coordinate system or a two-dimensional projected coordinate system? And within those folders, for example, inside the projected folder, there are all kinds of different options available. There's lots and lots of different projections out there, and they're designed for different characteristics. Some of them are good for measuring areas. Some of them look nice. Some of them are designed for different parts of the world. So there's lots of choices that are available to you, and in order to make an informed decision, you have to understand how map projections work and how you might want to use them. Let's compare a three-dimensional globe to a two-dimensional flat map. A globe is a three-dimensional model of the Earth. Now, those are a bit expensive to make, they're cumbersome, there's not a lot of detail, but there's no distortion. What I mean by that is that, it's fine to have a globe as a model of the entire planet, but what if you want to make a map of your neighborhood? Maybe you're having a street party, you want to show people how to get there. Do you really want to make a gigantic globe that you then have to, carry around and show to people and say, here's the map to our party. I made this gigantic globe that's at the scale that I wanted it at so you can see enough detail to actually see my neighborhood on it. It's not really going to work very well. And then, of course, maybe 2 weeks later, there's a soccer game going on. You might want to make another map for that. You'd have to make another globe, and you'd have to have a big globe for that. So, of course, I'm not trying to be ridiculous here, but I'm just trying to, explain why people like to use two-dimensional maps, is they're a lot easier to use. So if we look at our two-dimensional map, it's easier to create. It's easier to measure things like distances or areas or directions. You can show more detail, so you can blow up just one part of the Earth and show that easily without having to have this huge, gigantic globe. So they're a lot easier to work with, they're cheaper, they're more portable. But the problem is you're taking a three-dimensional world and flattening it down to a two-dimensional surface. And if that happens, you're going to get distortion. Now, a key theme in this whole section on projections is that distortion isn't necessarily bad. It's just a consequence, a fact of life, of trying to flatten a map so that it's easier to work with. The key idea here is that you have to sort of harness that and know what distortion is happening and where is it happening on your map, and is it happening in the way that you're okay with, that suits the purpose of the map that you're creating. To illustrate the effects of distortion, I'm going to use this website called The True Size Of. It's this amazing little website. So you literally just go to thetruesize.com. You can open this yourself and play around with it. And what this is for is to visualize the amount of distortion that's taking place based on the map projection that they're using. The map projection that's used here and is used in any web map is a version of the Mercator projection called Web Mercator. And there are reasons why web developers like to use it. We'll get into that a little bit more later. There's lots of reasons for it, but there's an enormous amount of distortion that takes place when you're using a Mercator version of the Earth. And this website is a great way of kind of illustrating that. So let's have a little fun with it. We can type in the location of any place that we want. I'm going to use Greenland here. And so this has highlighted Greenland on my map. Just move that up a little bit. And so what you'll see is that Greenland looks much larger than Africa. And that's not actually true. If I drag Greenland to Africa, you'll see the true size of Greenland is actually much, much smaller than Africa. Africa is actually 14 times larger than Greenland. So what's happening here? Well, it's because that we've used a map projection that causes this kind of distortion of the sizes of objects. I'll say this a few times during the projection section. it's not necessarily that this is a good thing or a bad thing. It's really just a fact of the projection that's being used, this particular one, and that depending on what you're using it for, that either might be an appropriate projection to use or an inappropriate one. So this is a great way to illustrate that, is that Greenland is actually much smaller. So if Greenland existed at the equator, that's what it would look like on this map. Okay, so let's move it out of the way here. Let's have a look at Canada, my home and native land. And so here's Canada. Whoops. Let's move this over here. And as you know, Canadians love to brag about the fact that we have such a large country. And isn't that great? And you know, what that really means, I don't know, but it's big. And yes, Canada is a big country. But let's just move it down to where the United States is. Huh. Well, okay, so it's not quite as large as I thought it was. It's still larger than the United States, I'll say that, but it's not that much larger. Let's look at Russia, for example. Russia is an enormous country, everybody knows that. But let's do the same thing. If we take Russia and drag it over here, much smaller. Looks big over here, not so big over here. Still large, but not as big as you might think. What's happening is that countries that are farther from the equator, so Canada or Russia or Greenland, which isn't really a country, but okay, they're larger, so they're being exaggerated in size. Whereas countries that are near the equator are meant to look, in comparison, end up looking much smaller. So that's all I really wanted to show you with this little app. You can have fun with it. It's a website called thetruesize.com. It's a really handy little fun thing. You can move things around, like wee over here, you know, look at that. All I really want you to get out of it at this point is that there are these dramatic distortions that can take place. Often they're ones that either we want to certainly be aware of, but also maybe take into consideration when we're deciding which map projection we may want to use.